Hey physics, here is our final test of the year, the review for the final test of the year. So this is 37 questions. I'm going to go through all of them, but you are welcome to skip through and just use what is useful to you. Whatever you're feeling confident on, you can skip it, or if you want to just check yourself real quick, that's always a good thing to do too. So when I post this video, I'm also going to have the answer key posted for you. So this is an ungraded assignment. It's up to you to check and make sure that you're doing okay on things, all right? So here we go, multiple choice. So what property of an object describes its natural tendency to resist a change in motion? Oops, let me just make a Mrs. Allen's copy real quick. So the answer to this one is going to be inertia. Inertia is the property that causes an object to resist a change in motion. It's not a force, it's just a property. So which two of the following statements are true? Inertia is the force that keeps a moving object in motion. Inertia is the force that keeps a stationary object at rest. So again, inertia is not on its own a force. It's more of a property, or like something that's just true of things. Inertia is the natural tendency of a stationary object to resist motion. Yup, things that are holding still want to stay holding still. And also, inertia is the natural tendency of a moving object to resist a change in its velocity. Also true. Okay, so when all individual forces acting on an object are balanced, it is the natural tendency of an object to... So when forces are balanced, then it is going to keep its velocity constant. It just doesn't want to go any faster or slower. That's basically just inertia. These are all inertia questions. And an unbalanced force is what causes an object to accelerate. That's what we'll see in a minute. So here are so this whole one is for Newton's first law, and this whole one is Newton's second law. So which of the following is always true of an object that is acted upon by an unbalanced force? Always true of an object that is acted upon by an unbalanced force. The object is not at rest, because there's a force that's overcoming another one. The object is moving, but more specifically, the object is accelerating. Well, let's think about this. Is it accelerating or is it moving? An unbalanced force. Okay, so the difference between moving and accelerating here, the answer is accelerating. And the reason why is that an object that's moving, if it's moving at a constant rate, hold on, I gotta get my different color here. If the object is moving at a constant rate, then that means that its forces are balanced. So yeah, the unbalanced forces causes acceleration, a change in speed, going faster or slower, or a change in direction. Okay, so a stationary object experiences a rightward force of 5 newtons and a leftward force of 3 newtons. So you should be picturing that in your head. What would that force diagram look like? How will the object move? So 5 newtons to the right and 3 newtons to the left. You guys are looking at it's opposite on the screen. But so it's going to move to the right with a force of 2 newtons. Because this one has 2 more newtons than the other one. It will accelerate to the right. Yep. Okay, which of the following objects is accelerating? A baseball player slows to a stop while diving into third base. A ball speeds up while rolling down a hill. A race car moves fast along a straight section of track at a constant speed. So it's definitely not this constant speed one. Accelerating means that the speed is changing. It's going to be this one. A ball speeds up while rolling down a hill. And this one would be deceleration. So there is deceleration going on there, or negative acceleration if it is, depending on the direction that you're thinking about there. But definitely a ball speeding up while rolling down a hill. Okay, the diagrams below depict the individual forces acting upon an object. Each arrow represents a force, and the length of the arrow represents the size of the force. Based on this information, which objects could be moving to the right at a constant speed? Okay, So to the right at a constant speed. So I am thinking about unbalanced forces here, and balanced forces. So the trick here is that it's saying it's a constant speed. So my first instinct was to say this one or this one, because there is a stronger rightward force than there is leftward force. But if it's moving at a constant speed, if it's not accelerating, then it's going to have to be this one. So that is my option there. Because a constant speed shows that those forces are all in balance, even if it's moving already. If it's not accelerating or decelerating, then those forces are balanced. Okay, so write the correct letter in the black oval to answer. Hold on, I just want to think about this. I just wanted to come back to this one again real quick just to explain a little bit further why a constant speed is telling us that it's this one and not this one. So the idea behind these two is that as long as that force is like unbalanced in that direction, then there's going to be more and more acceleration. What would cause like in real life and in this situation too, what would cause it to not accelerate any further is that the force of friction or air resistance or there's going to be some other force that eventually becomes balanced with it. So like if you're driving down the highway and you've got your foot on the gas pedal, but you're going like 70 miles per hour. But if you're like going 70 miles per hour at a constant rate, then the forces are balanced. That friction is balanced with the amount of force that you're putting on the gas pedal. But if you hit the gas pedal harder, then there's going to be more force pushing you forward, and that's going to cause an acceleration. But yeah, so think of this as like that push that's getting further and farther forward, or further and further to the right, until it reaches that point of equilibrium. Okay, sorry, I know that was a long explanation. We're at 7 minutes already, my gosh. Mac and Tosh are arguing in the cafeteria. Tosh says that if he flings the jello with a greater speed, it will have greater inertia. Mac argues that inertia does not depend on speed, but rather on mass. Who is correct? So Tosh is flinging it faster, but Mac is throwing a bigger piece of jello. So inertia only depends on mass. So Mac is correct there. Think about like the moose or the bus versus the bird, or like you on your bike. The bigger things are going to need a lot more force to move them, to change their direction. So which statement is true of an object that has an acceleration of 6 meters per second every second? So it's getting 6 meters faster, or traveling 6 meters more every second. The object changes its velocity by 6 meters per second. Yes, but I want to keep reading, make sure that's the best answer. The object moves with a constant speed of 6 meters per second. No, it's definitely not that one, because this is saying it's moving 6 meters per second faster every second. The object changes its velocity by 6 meters per second every second. There we go. So yeah, that is the best answer there. The object moves at a distance of 6 meters per second. More each time would be the way to make that correct. Yeah, so this changes its velocity by 6 meters per second. If we were looking at that on a graph, that graph, if it was a position time graph, that would give you a velocity that is steadily increasing. But if it's changing its velocity by 6 meters per second every second, that's going to give you that curve that shows acceleration. Every second it's traveling 6 meters more. 6 meters further. Okay, how can the velocity of an object be determined from a position time graph of its motion? Okay, how can the velocity of an object be determined from a position time graph of its motion? So if you think about this, where can we see the velocity? What is the velocity shown by? So the velocity is the change in the vertical coordinates. So how like how much is its position changing. Like that kind of works. Let's keep reading. The velocity is the change in the horizontal coordinates. So that's definitely not going to be it. The velocity is like, this is time. So that would be like 1, 2, 3, 4. So that's time and not velocity. The velocity is the ratio of the vertical to the horizontal coordinate for any given point. That sounds kind of right too. Let's think about this again. The velocity is the slope of the line on the graph. That is definitely the answer. Because if you were going to define what this is, like if you're going to look at any given point on there, it would be like how far have they traveled and how much time. So the slope of the line is telling you how fast they are traveling, how far they've traveled in a certain amount of time. Miles per hour, meters per second. Okay? Consider the graph shown here. Which of the motions is consistent with the graph? What kind of motion is this graph showing? So the object is moving away from the starting point and speeding up. Okay, yes, it is moving away from the starting point and speeding up. The object is moving toward the starting point and speeding up. No, because it's starting at zero, a zero position here, and it's going farther away. The object is moving away from the starting point and slowing down, so that would be more like this kind of a shape. It'd be like a vertical flip of this picture right here. The object is moving toward the starting point and slowing down, so that would be like starting up here and coming down like that. So this is going to be A right here. And you can figure these out. This is like, I want you to be able to look at this and be like, okay, and like reason it through, figure out what the slope is saying. This is a shallow slope, meaning its position is not changing very quickly over time, and then it gets steeper as time goes by, more change in less time. Okay, multiple choice. Okay, Newton's second law says the presence of an unbalanced force will accelerate an object, changing its speed, its direction, or both its speed and direction. Which of these can be explained by Newton's second law of motion? Okay, the presence of an unbalanced force will accelerate an object, changing its speed, its direction, or both its speed and direction. So why a stationary object remains stationary? That's inertia, so that's Newton's first law. Why every force is accompanied by a reaction force? That is true, but that's not what this law is about. Why an object accelerates with a certain amount of acceleration. Yeah, that's that one. Okay, so an object is accelerating. What can we say for certain about the object? The object is not experiencing any force? No. If it's accelerating, there's definitely an unbalanced force on it. The individual forces acting upon the object are balanced? No, because if they were balanced, then it would be moving at a constant speed, whether that's 0 speed or whether that's 7 meters per second, right? There is a force acting in the direction of the object's motion. So there's something that's moving it in the direction it's moving in. Yes. The individual forces that act upon the object are not balanced. That's definitely true. So this one I wanted to come back to it because that's one of those where you have to like think about it a lot. There is a force acting in the direction of the object's motion. So that is most likely true. But this is definitely the best answer. But that one's kind of true. Like because that would be the thing that's pushing it to be accelerating. Like there is a force acting on it in the direction that it's trying to move in. So yeah, I mean, you could really say both of those. I'm going to go ahead and highlight that too. Okay, a net force acts upon an object. What can be known for certain to be true of the object? Okay, a net force. So this one isn't really saying anything about what that net force is. Meaning, I'm guessing that this is like a non-zero net force. So, I mean, really, it's going to be like, it could be any of these, really. Could be a net force of 0. There could be a net force of 15 in one direction. There could be a net force of, 300 in the opposite direction. So, really, any one of these is true because a net force is just saying, like, that there